Okay, so our next skill is graphing translations of rational functions. So the translations, remember, refers to the AHK form that we use. So our general form again, or our parent function, is y equals 1 over x. And to transform that, we have y equals a over x minus h plus k. So as with all functions, a is going to be our vertical stretch. And if it's negative, it will flip the graph. So instead of being this shape when it's positive, it will be this shape when it's negative. So notice this part is now up above the axis, and this part is below. Our h is our horizontal shift. So that's going to move it left to right. And remember, because we have this negative in the original equation, the sign is the opposite. And then our k is our vertical shift. Okay, so that's going to shift the whole thing up and down. Now, this is the same as what we've been doing with all the other functions we've studied this year, but there's one interesting feature to this that can help us in graphing these, and that is that because we're starting with an asymptote here of x can't equal 0, or sorry, the asymptote is at x equals 0, then when we shift it from there, we're just shifting from 0. So h becomes our new asymptote. So x equals h is our vertical asymptote, right? Because it goes up and down. And y equals k is our horizontal asymptote. Okay. So that ends up being pretty nice and handy. So let's look at an example. If I have to graph the function y equals negative 3 divided by x minus 1 plus 2, my a value is negative 3. My h value is, this is minus 1, so it's going to be positive 1. And my k value is 2. So I'm going to show you two different ways to approach this. One is to start with the asymptotes and make the table, and the other is to do the table transformations. So if we just think about the asymptote, x and y. So before I started my table with 0 in the middle, because that was where my vertical asymptote was. Now my vertical asymptote is at 1 because it goes with your h value. So I know that at 1 I'm not going to have any points, and so I'm going to use that as the center of my table, and then I'm just going to find some points on either side. So going this way, I have 0, negative 1, negative 2. Going this way, I have 2, 3, and 4. And then I'm going to substitute those numbers in to find my points. So 0, negative 1, so that's positive 3 plus 2 is 5. Negative 1 minus 1 is negative 2, so that's positive 3 halves plus 2 is 3.5, -3, so that's +1, so this is 3, okay? And then going the other direction, I can then again just use that symmetry, so this is going to be sorry, 2 minus 1 is 1, -3, so this is -1, 3 is 2, -3/2 plus 2 is 1/2, and there's 3, -1, so this is 1. So now I'm going to sketch in my asymptotes. So I have x equals 1 and y equals 2 as my asymptotes. So here's x equals 1. And here's y equals 2. And then I can sketch in those points. So at 0, I'm at 3, 5. At -1, I'm at 3.5. At -2, I'm at 3. So this is going to kind of be this shape. That. And then over here at 2, I'm at -1. At 3, I'm at 1/2. Oh, sorry, I put that negative. This should be up here. And at 4, I'm at +1. So here we go. It is really hard when you have two asymptotes and your two axes to like not mess up when you're counting points like I just did. So I highly recommend using dashed lines and different colors so you can clearly tell which is your axes and which is your asymptotes. Alright, and then I have, this is x equals 1 and this is y equals 2. I'm going to label those, and there's my graph. Alright, so then the other way that we could build the table is -3 over x minus 1 plus 2. Using our 4-column table. So if I have my x and y of my parent function, which was y equals 1 over x, and I go -3, -2, -1, 0, 1, 2, 3, then I can go -1/2, -1, 1, 1/2, 1/3. This is always ay plus k. This is always x plus h. We already said a is -3, h is +1, and k is 2. So here I'm just going to take all of my x values and add 1. So -2, -1, 0, 1, 2, 3, 4. And then this is still going to be my asymptote. This is negative 3y plus 2. So this is 1 plus 2 is 3. And 5, negative 1. What am I doing wrong? Yeah, that's right. I just blanked out. So you get the points, and then you would graph them again. Okay.